Alright, based on the three-sided links you are given, classify the triangles by sides, then by angles. Alright, so step 1, confirm triangle. Confirm that he even makes a triangle, alright? We have the good old triangle inequality. So basically that just says pick your two smaller sides, in this case 3 and 4. They must add up to be greater than the biggest side, 5. So yes, you can make a triangle with this. Alright, do I have to see this work every single time? No. But it's a good habit to form. Now, second is we're going to plug into Pythagorean theorem. Alright, if Pythagorean theorem is true, it's a right triangle. Alright, so we can even write that down really fast. A squared plus b squared equals c squared. That means it's a right. A squared plus b squared is less than c squared. That's obtuse. And then a squared plus b squared is greater than c squared. That's acute. Alright, and why do we do stuff like this? Why do we care so much about this? Triangles are so important in terms of math. Alright, in terms of shapes. They're the building blocks of all other shapes. So if we can master the triangle, well then we can master the hexagon, the pentagon, the octagon, a square, quadrilateral, so on and so forth. Alright? So Pythagorean theorem held to be true, so that means it's a right triangle. So I guess the last thing to do is just answer the question. All three sides are different, so it's scalene. And then Pythagorean theorem worked, so it's a scalene right triangle, or a right scalene. Alright. So really fast, confirm it's a triangle. 6 plus 6 equals 12. Which is greater than 11. So yes, you can make a triangle with these lengths. Now I'm going to plug it into Pythagorean theorem. So I like to do 6 squared plus 6 squared, gap, 11 squared. I'm not going to say it's equal, greater than, less than. I really just got to compute it and find out. I'm going to get 36 plus 36, or 72, 121. 121 is clearly bigger. Hopefully you can understand that. So now when I classify this triangle, it's obtuse because of this rule right here. And then two sides were the same, so it's obtuse isosceles. Alright. And then this one right here, 2, 4, 7. 2 plus 4 equals 6. Is less than 7, so it's not a triangle. Not a triangle. Wah, wah, wah. It's crying. Alright, then we move on to special right triangles. Alright, remember you guys are even going to do Unit 7 in GAC 2. To me, it's probably not, I would make an argument that's the most important unit in the geometry curriculum. Just a great great stuff you can do with a lot of things. Let me think about how I want to do this. Alright, just to review the rules really fast, I'm going to discuss. There's two special right triangles. This is a 30, oops, that should have been the 60-degree angle. 30, 60, 90. Alright, remember we have the short leg, the long leg, and the hypotenuse. Alright, now, if the short leg is x, to get to the long leg, you're just going to multiply by radical 3, and you have x radical 3. What if you're given the long leg and that's y? Well, there's two ways to go about it. You're either multiplying by radical 3 over 3, or you're dividing by radical 3. That's how you get to the denominator. So x would be x, or excuse me. If the long leg is y, the short leg would be y radical 3 over 3, or y divided by radical 3. Kind of cramming my work in there. And the hypotenuse, we'll just write this in English. Always short leg times 2. Alright, so let's just focus on all the 30, 60, 90s first. Now on 30, 60, 90s, I like to say this, short leg ASAP. Alright, I want to get to the short leg ASAP, and then the last remaining side, whether it's a hypotenuse or long leg, it just kind of falls into place. So here, I'm given the long leg. So what I'm highlighting in orange right now is when I'm given the long leg. It's 6 radical 3. So this would be a case where dividing by radical 3 is easier. I'm just essentially removing it, boom, have a 6. Alright, the short leg is 6. And then the hypotenuse is just always doubled the short leg, because remember we cut a equilateral triangle in half. If you can remember back to the notes, boom, that's it right there. Alright, let's see, do I have any other 30, 60, 90s where I'm given the long leg? Yes, let's look at E. Alright, E is the same problem. This is kind of nice. Here's the long leg. I have a radical 3 in the answer. So to go this way, I'm just going to divide by radical 3. So basically I'm just removing it, and the short leg is 3 over 2. So these problems would be very complex to try to use Pythagorean theorem or anything else. But if you know these rules, you'll understand it. Look, I just found 2 missing sides of a right triangle in a matter of seconds. Difficult, hard, students struggle with it, but I know some of you guys are doing phenomenal. Alright, now let's look at these other 30, 60, 90 triangles in D, and then this one just floating right here. Doesn't have a number or a letter for some reason. D, it's always a little easier when you're given the short leg first. I can go anywhere I want. I'm just going to get the long leg first. Remember, you're just always multiplying by radical 3, so the long leg would be 3 radical 3 over 2. And then to get to the hypotenuse, always just multiply the short leg by 2, so the hypotenuse would just be 3. And here's the last one right here. We're given the hypotenuse, not a big deal. Always just get the short leg first. So the hypotenuse is always just double the short leg, so to find the short leg I'm dividing by 2. Just going in reverse, reversing my thinking. So the short leg is 5 over 2. So then the long leg is just going to be the short leg with a radical 3 at the end. Long leg is 5 radical 3 over 2. Boom. Alright, that's it for 30, 60, 90s. Alright, apparently a lot of preview right there. Those are the more difficult ones in my opinion. My favorite right triangle is the right isosceles, the 45, 45, 90. Alright, so I'll just draw the picture here, extreme close-up. Alright, when you're given the leg, so when you're given a leg equals x, the other leg is x, because it's a right isosceles. We know that because it has 2 angles that are the same, so 2 legs must be the same. The hypotenuse then is just whatever x is times radical 2. Alright, that holds true no matter what. Now, what if you're given, let's do it in pink, what if you're given the hypotenuse is just some number y? It can be as goofy or as simple as you want. Well, then to get to the legs, there's 2 ways to think about it again. You're either multiplying by radical 2 over 2, or dividing by radical 2. Those are the same thing, just rationalizing the denominators. We practice that dividing radicals. So the hypotenuse is y. The legs will either be y radical 2 over 2 or y over radical 2. So in this case right here, in this problem right next to me, this is the hypotenuse. It's 5. Since there's not a radical in the hypotenuse, this will be the more useful. Alright, dividing or multiplying by radical 2 over 2. And those two numbers, u and v, are just going to be the same. I'm just going to multiply by radical 2 over 2. So u will be 5 radical 2 over 2. V will be 5 radical 2 over 2. So realize radical 2 over 2, radicals, whatever, they're just numbers. The quicker you can realize that and accept it, the easier time you're going to have with this, alright? Now, in this one right here, this is like when we're given x, the leg. So I automatically should know that y is radical 2 as well. Now, how do I go to the hypotenuse? You just multiply by radical 2. So radical 2 times radical 2 is just regular 2. Because radical 2 times radical 2 is radical 2 squared. The square root and square undo each other. And that's that. Alright, now let's just talk about trig ratios really fast. And then we'll do the last page of GAC 1. Alright. So we're focusing on B right here. Alright, so if that's the reference angle, this is the adjacent side because it's the leg that touches B. This right here is the opposite side because its leg don't touch B. And then the hypotenuse has no, it doesn't matter what angle we're talking about, the hypotenuse is always the hypotenuse. Alright, it does not matter if we're talking about the reference angle A or the reference angle B. Okay. Then we have our good friend SOHCAHTOA. And then these trig functions right here, sine B, remember that'd be opposite over hypotenuse, which in this case would be 4 over 5. Cosine of B, adjacent over hypotenuse, which in this case would be 3 over 5. And then we have tangent of B, which is opposite over adjacent, which in this case would be 4 over 3. Nice. Okay, and we'll finish these notes in the last video.